This is Mohammed from Python Ninja, and in this tutorial, we will learn together how can we combine two iterable objects like list tuples together using zip function. Zip is a built-in Python function aggregates item or element from two or more collections data type. For example, if you have two lists or two tuples, or one tuple and one list, and you want to aggregate each item from the first collection or iterable object to the corresponding one in the other corresponding iterable object or collection, then you can use zip function. So it assign both items based on their index. Okay, it assigns them to one group. Okay, also zip can create or it creates a zip object, which is a type of Python generator. This is on-demand iterable object, meaning that if you perform looping into this object, you can do this for one time. For the second time, this will be erased from the memory. So it is a lightweight version of the iterable object, and this is computationally wise methodology. In next tutorials, not the next one, but in one of the next tutorials, we will highlight Python generator data type, but I am now going one by one since the zip is related to iter tools and iterators, so I decided to keep it here. But remember that the object that will be resulted from the zip, you can use it to loop for one time. Okay, suppose that you have a list of names. For example, I have the names, and in the first name, you have my name, you have my son, and there is, for example, John, and we have also, this is a iterable object or data collection data type of type list, and we have another collection data type which will be in type of tuples, which will hold the ages, for example, 2, for example, 30 or 45. So what if I want to give each name with the age, and I want to back them together? Okay, I want to do zipping or backing to each element from the first iterable to the second one. Then what I can do, I can say, for example, I can define a new variable, and I say this variable is a zip object, and this will take the first iterable and this will take the second one. Okay, remember that if you want to print info directly, then it will be the memory address of this object, and this is a generator or like lightweight iterable object. You can loop into this object that is located in this memory for one time. Remember that if you pass one argument here, you will be also able to print the items. Let us print or let us unpack these items. We can do just using list or for loop. When we list now, as you see, we have only one item, okay, in the zip function, and the second item is kept empty. If I want to assign the age here, okay, then I will have Mohammed and his age become now a pair to each other, okay, and now Furat and the age pair to each other. So if you have two separated collections at a type, and you want to or iterable and you want to like make marriage to them, or you want to make assignment to each item or with corresponding one, you can do that. Suppose I remove John from here, then it still works because it will consider only the limit of the of the of the shortest iterable object here. If I remove the second one, then I will still have the same result because it looks for the shortest the shortest iterable object, and it builds the list of tuples based on that. Okay, so this is to engage two iterable object data type. So you let us just hide this. I can do for loop, for example, for like the item in info. I want to print the item, okay, and as you can see here, we can print them or we can iterate over them. But if I want to just to print this star separator, okay, and then I want to loop another time after this star separator, okay, here let us check that it will print nothing. So this is the first loop here, okay, and then I print this separator here, and looping again is not allowed because once we loop to this info, it will be erased from the memory because it is a generator which allow looping for one time, or it gives on-demand iterable object that if you loop through it, it will become empty. So as you said that we can unpack the zipped item using the list, okay, and if you see the result here, it will become a list of item. We can also unpack this into dictionary. For example, instead of using list, I can use dict, and this will give me the first item to be the key, and the second item will be the value of the dictionary. If I run this, as you see here, it is not a list of dictionary, but it's not a list of tuples or a list of dictionary. It is a dictionary where the first item, okay, is assigned to the first value. Okay, and the names now become keys and the ages become the values. Suppose I have a heterogeneous iterable collection, meaning that I have another collection object that, for example, will hold the emails, and let us just choose to be with a tuple. Okay, suppose I have three emails corresponding to three guys. Okay, for example, I have the first one A at A. Let us use the second one B at B, and use the last one C at C. Okay, suppose these are these are the emails. Okay, that is associated to each one of these. Okay, now I have heterogeneous data type. I have list of string. I have tuple of numbers, and I have list of string. Okay, so I can also zip more than two iterable object. I can add the emails. Okay, and I can back this to the list. As you see here, the dictionary will become a problem, and you will unpack this, okay, again, and you will see here you have a tuple of the unique information for each one. For example, here we have the name, you will have the age, and you will have the email address for that one. So based on that, we can say that we can do zipping or packing for iterable objects, okay? And we can do unpack again when I use the list, or I can do looping for that. Suppose you work in, let me just have this here. Okay, suppose that you work in a genetics, for example, field, and you have two DNA sequence where the first sequence, okay, is represented using this string representation, and this is, for example, well known as the biologist or biotechnologist, and we have a second sequence that is represented based on this. Now, we seek for a methodology that will check if this two sequence are identically represented, meaning that A and there is corresponding A from sequence 2, and from sequence 1 we have T in this index, we have T. but we have here in this index, we have B, but it is A. The task is that we need to loop in this and check the items, okay, of the sequence or the index of the item of the sequence if both values are not equally represented. Okay, the implementation, if you think of this, you want to loop, you can do transfer this string to a list and this to a list, and you can make a very long loop through each item of the list. That is time wasting. You can use zip function directly. For example, I want to do zipping for this sequence, and this is nothing but zip for the first sequence and the second sequence directly, instead of like unpacking this string to a list. I use it directly. Now I can perform the for loop to inside this generator. Okay, but how can I inform the for loop? Now I will use three items. The first one is the index. For example, for I, which is the index, then I want to use the tuple. Okay, because I have this zip function will give me tuples. So I will have A and B, which is the first item in this tuple, and B, the second item in this tuple, and both are in enumerate of what, of the zip sequence. Okay. Now here is the condition: if A, which is this one, okay, this sequence, if the item here does not equal, okay, does not equal B, then what we will do, I will also here define a global index, okay, and I will say the global index is none as an initial value. Now if A not equal B, will not equal B, here all of these items are equal to this item except we have here, then I need to know the index. Then this I give me the index. So I want to say global index, okay, equal to I. Okay, sorry, global index. Yes, it is. It is the index. Yeah, here the global index is equal to I, and I want to print f. Okay, the for example, the index is is I here, which is the index is I. Okay. Now we can also do another print here. Okay, using the f string. What I can say can both sequence, okay, are are different. For example, at index, which is the global, which is the global index, we can do something also like, if you want to print more, we can say sequence one value, and this will use this quotation. We will say sequence one of a global index, and I can say sequence 2 value, okay, and this will be this will be sequence 2 of a global index, of a global index. If I execute this code, I will see at index 20. Remember, we use index 20, but actually it's a 21. So it depends on how you want to represent this. Okay, so we can add one, okay, because we start counting from one, but in Python, again, the counting starts from zero. So this is index zero. But if you want to translate this to a human or non-Pythonic way, so you can add just one here to start from one and from zero. And if you go and count, you will find A and B here are located in the index number 21. And you can see both are different in A and B. This is a direct implementation on the function, and that's for today's tutorial. Please keep following this channel and share this video, and see you in the next tutorial.